Hi, my name is Keith Neeves. I am an assistant professor in chemical engineering and part of the rapidly expanding bioengineering program at the Colorado School of Mines. And I'm quite excited to be here for a number of reasons. I'm actually a native of Colorado, and like the Waring family, I came to Denver via Colorado Springs, where I was born and raised. And the Boettcher Foundation has been particularly generous to my family. My wife is actually a Boettcher scholar. Now I'm a Boettcher investigator. And so to really complete the hat trick, all we got to do is have Boettcher build us a building, and we'll have all the things at school. And so this lab, what my lab works on are the mechanisms of how blood clots form. And we're interested in both the diagnosis and the treatment of bleeding and thrombotic disorders. And so to give you a flavor for what we do, we're really good at technology development at School of Mines. And so we've developed some technology in my lab to predict how good of a blood clot you can form. And so it's a little microchip, it's about the size of a stamp, and it takes just a drop of blood. And so we use the same techniques that are used to make the integrated processors that are in your computer, but instead of flowing electrons, we flow blood. And we're able to simulate exactly how a clot happens, or close to how a clot happens in vivo. And so we work really closely with some clinicians at the Children's Hospital of Denver, and we're in the middle of a kind of clinical evaluation of this technology in diagnosing and treating genetic bleeding disorders, things like hemophilia in a large pediatric population. But this award is going to allow us to go into a new field that's new for our lab, and that's looking at anticoagulants and coming up with new anticoagulant strategies, which is a much larger problem in terms of the number of people that it affects. And so, but we've been able to tease out some interesting clues from our work with bleeding disorders. And so if I was going to make the ideal anticoagulant, it's one that inhibits thrombosis, which is the excessive clotting, but doesn't interfere with the normal process of forming a blood clot. So this is the problem. Most anticoagulants have the side effect of causing bleeding, and so that's what we don't want. But it turns out there's a fairly rare hemophilia. It's called hemophilia C, or factor 11 deficiency. It's quite common in a few ethnic groups. So it's common in Ashkenazi Jews, and we have some collaborators in Israel, and they've done really fantastic clinical work. And over the last 40 years, they've studied hundreds of people with very severe disorders, severe disorders in this protein called coagulation factor 11. And it turns out that not a single person has had a stroke in this big cohort of people who have had factor 11 deficiency. So it gives us a clue. These people, this protein confers protection against certain types of blood clots. And so these people also don't get deep vein thromboses at the same, so the big clots that form in your legs if you sit on a plane too long, they don't get those at the same incidence as well. And so the purpose of what we're looking at in the grant is A, why does this happen? Why are they protected against some kind of clots and not others? Do they still have heart attacks at the same incidence as the normal population? And can we exploit this protection against things like stroke as a possible drug target? So that's what we'll be looking at. And thanks again to the Boettcher Foundation and the Waring Foundation.